Hey everyone, we are going to solve LeetCode problem finding unique binary string. So this problem is of backtracking. So according to this question, we have to produce a unique binary string, a binary string that have either 0 or a 1 character. So as you all know that when you have to produce a string of length 2, so the total possible combination will going to be 2 raised to power n. For example, when you have to produce a binary string of length 2, the total combination will going to be 2 raised to power 2, that is 4. So this includes either 0, 0, 0, 1, 1, 0 and 1, 1. So according to this problem, we have to maintain this all combination in a hash table, which will going to which will help us to produce a unique string. Uh, so what does it means that? So we are going to put all these nums array into our hash table, and when we produce unique string, we will going to match in our hash table whether that particular string is present in our hash table or not. If that unique string is not present in our hash table, we will going to return this into our output. So let's see about time complexity. You are given a constraint n lies between 1 to 16. So you can produce a solution of 2 raised to power n. So the 2 raised to power n will going to be less than 1 second. That is at max n is given to us, n lies between 1 to 16. 2 raised to power 16 is less than 1 second, so this solution will going to be accepted. But in a real scenario, we are not we will not use this 2 raised to power 16 time complexity, as you can consider a scenario that when I have put my all nums array, that is nums input which is given to us, when I put this nums array into my hash table, suppose 0, 0, 0, 1 and 1, 0. Now I have written an algorithm which is going to produce me all the combinations one by one. Suppose this algorithm produces 0, 0 combination. I will going to check this into my hash table. Is it present in my hash table or not? It is present, so it is not a unique string. So now the next string that my algorithm produces is 1, 1. So I check into my hash table whether this is present in my hash table or not present. So this 1, 1 is my unique string. So according to this problem, you can return any of the solution which is a unique. Either it can be a 1, 1 or anything else. So here total 4 combination are possible and 3 are already present. So here only one unique string is possible. So let's see about how we can produce string lexicographically order. So at 0th index, now suppose we are given n equals to 3. We have to produce all the combination of this 2 raised to power 3 combination we will going to produce. As you can see this in our example 3, we will going to put all these nums array into our hash table, and we will match this with our algo's output whether the particular string is present in the hash table or not. If it is not present, so that string will be going to be our answer. So you have to fill these three indexes. So what I will going to fill at 0th index, either 0 or 1. So at the first index you can fill either 0 or 1, and at the second index also you can fill either 0 or 1. At the 0th index, let's see. Here I have filled my 0th index position with 0, and here I have filled the position with the 1. Here I am checking all the two possible cases because it is a binary. So we have two possible combination at n equals to 1 index. So when I follow this path, so I have already filled the 0th index. Now I will going to fill the first index. Either 0 I can fill this, or either 1 I can fill. At first index I will going to put 1. Similarly you will going to follow till n equals to 2. Here also. So now when you suppose this is your root node, when you follow this path and you reaches from root to leaf, we follow a path. When we reaches the leaf, leaf means when n becomes equal to 2. When you reaches the third index, you will going to see what is your string formed. The string formed, suppose the current form is 0 0, and in the hash table, this is our hash table, and in the hash table we will fill it with the input array. So the input array consists of 1 1 0 1 1 and 0 0 1. 1 1 1 0 0 1 and suppose 1 1 0. Now you matches this with match the string with our hash table. So you find out that 0 0 is not present. So you will going to return this path true. So that will be our answer. So here when you get the true answer, you will not going to check this further branch. So at most you will going to check n plus 1 strings. So the time complexity will going to be, there is the string formed is of n length, and the input array given is of n. So n length string, suppose these are the strings, so the array size of n and the string size is of n. So the time complexity will going to be O of n square, and to maintain these all string into our hash table, we will be required a space complexity of O of n square. This is at the worst case. So let's code out this problem. So let's initialize our current, which will going to form all the possible string such as 0001. This is that we are forming in the path, and during the backtrack we will going to pop out the elements. We will going to form a hash table of string. In this hash table we will going to insert all our input. Let's pass this all this parameter into our build function. Now, and in the global variable we will going to maintain a result variable which will hold our output. So the function we are going to form is of a build. So we are passing this current and number its reference so that no copy is going to form. Suppose when the string formed reaches to your end index, so then you are going to check into your hash table whether this is present, the unique string is present in your hash table or not. So on successfully finding the unique string, you will going to return this as your output. If not found, you will going to return false. Now we will exploring all the possibility. What will be at the first index, second index, and further on. We are going to push back 0 into our current. So the combination that we form after inserting 0 at any of the index, when it returns true, it means you have successfully formed. Else you are unable to form a unique string, you will going to pop back that character from the index. Let's insert another possibility. Here also we are going to check whether this possibility at any of the index I have inserted one, whether it will going to result me unique string or not. If successful, I will going to return a true, else I will going to pop back. At last, after exploring all the possibilities, if I am unable to form the unique string, I will going to return answer false. At last, we will going to return our result. So let's check the code. And this line is correct. Correct is initialized correct. Inserting all the inputs, created a function build, passing all the parameters, current, number, and created a result variable. Okay, reference correct, current dot size if it is equals to n. Okay, we have reached and checking the count. If it is a unique string, so the hash table will going to return the count of that unique string 0. If it is already present in the hash table, it will going to give me 1. So if it is a unique, then I will going to initialize with the current with result and returning true. Okay, if it is not return false, exploring all the possibility, current, number, and return true. At last popping back, this is the backtracking. So when you are backtracking, you have to remove all your possibility that you have chosen at that particular index, so that you can choose another possibility at that index. Okay, fine, let's check this code. Okay, so here we have come up with a solution of time complexity O of n square and space complexity O of n square. So let me remind you of the possibility diagram. Suppose in the hash table 00 is already present. You have followed this path and find out that 00 returns me a false. So I will going to track back to my n equals to 1 node. I will pop this 0 out, and instead I will going to explore this another possibility 001, and in this hash table I will going to check if this string is already present or not. Here if it is not present, we will going to return true and we will not going to check the further branch. Let's suppose if this 001 is also present, this is our input. So we have initialized this hash table at the time when we inserted all the input in our hash table. So if this 001 already present in our hash table, we're going to track back to this n equals to 0 node again and explore this possibility, another possibility f, and if find out that suppose 100 we have got at n equals to 2. If this is not present, we are going to return true. So okay, thank you, this is my solution. You can check out my code here. I will going to paste this into comment section. Thank you.